Finally, guys, here's the cool one. For me, this is really the cool one. And again, it's all about the cyclic quad. We're looking in this video at the exterior angle of a cyclic quad. And I've put it all up for you. You can see the story, I believe, and I hope. Of course, angle B, which is inside the quad, you can see it is equal to the angle here outside. So this A here, maybe if I can call this point, let me not say call it anything because there is a name for this point. So I'm just gonna show the label of the point now so that we can be, on the same par and have the same discussion in this regard. So you can see here that angle CAE, which is the exterior angle of this quad, of the cyclic quad, you can see it is actually equal to angle B, which is the interior angle. Now, if you remember from triangles, we spoke about this theorem since grade 8. You know that if I've got those two angles and this angle here, then the sum of two opposite interior angles is equal to the exterior angle. Now here we are doing this in the case of a quadrilateral. Guys, the exterior angle of a cyclic quadrilateral is actually equal to the opposite interior angle. And this can work either way. You can see I've given you only two cases in this case. Here is another one, angle BDE. You can see that BDF rather, you can see it is actually equal to angle C. And angle C is the opposite interior angle of that angle. I could have drawn another line here. I could have drawn another line there. I could have drawn another line going in this direction. But I challenge you to go explore that on your own. You can download GeoGebra, guys, on your cell phones. You can download even Desmos on your cell phones and go and explore more cases that I'm talking about here. So it's just that because of time constraints, I'm not able to really get to all the cases, but the best I can do is to sell the idea to you so that you understand the concept. So as usual, let's have some fun and see the different cases in which this can come. There's really nothing much to say about this because the theorem speaks for itself. So even if I move this, check how I've moved it, you still need to realize that B is the opposite interior angle and it is opposite to angle CAE. And this is where I've seen students being caught up a little bit because things have been moved around. In this case, again, someone would hardly see that actually angle BDF is the opposite exterior angle in relation to the angle. Well, it is the exterior angle, but the opposite interior angle is C. So sometimes examiners do this. They bring the stuff really close to one another, and then you start to get confused. You need not to start to be confused, guys. Look at the principle. And this is all, this is what math is about. When you follow the rules of the game, you will win. You'll not just win, you'll actually enjoy the game. And so math is about rules. And I'm sure you know that. Rules from algebra to geometry to trigonometry, all these different topics have got rules. You just got to make sure that you embrace those rules if you want to enjoy the game. Look at this other case also here, which looks a little bit awkward if I bring this two lines, those 2 points together. But you can see the relationship, guys, still holds. The relationship still stands. It has not changed in any manner. This angle there is still 47 and it's still the opposite angle, it's still opposite to the other one there. So it doesn't really matter how I get to play with this, where I position it and all that, it will always be true. And of course, Mr. G, for now, I'm just exploring this with you. I haven't come to a point of proving this. And of course, there will be videos in which I prove this. So hang on, look at this, another case. This is the obtuse case, of course. I hope you can pick this up. Look at B there, 136, quite big. And guess what? That's the exterior angle. And here's one thing that I want to point out as I conclude now. Things should make sense. You can see this angle here is what? Is obtuse. And of course, that can't be an exterior opposite angle. I mean, interior opposite angle. That should be the opposite interior angle. So also consider those things. Check, are you having an obtuse case or are you having an acute case, so that you can kind of make sense. Let's look at this case also. Here, the exterior angle is acute. So we need an interior angle, which is also what? Acute. And it can't be the one on the same line as the exterior angle. No, it has got to be that one up there, which is B in this case. Here you can see also the exterior angle here is what? Is obtuse. So and it can't be this angle here, although that angle is obtuse, but it can't be that one because on the same line, it has got to be that one there. I'm just doing this in case you still find it difficult. Otherwise, I hope you have enjoyed. Cheers.